Alright, so this whole unit is going to be on something called stoichiometry, and this is not entirely something new. This is using the train tracks or the conversions that you learned first semester, and we're just going to be taking it a little further and using it with our chemical reactions. So just follow along with your packet. What is it? Stoichiometry is the calculation of amounts of substances involved in a chemical reaction. So in your chemical reaction, the moles, to figure out how many moles you have, you are going to use the coefficients. And the coefficients will tell you the number of moles of each substance. So the coefficients in your chemical reaction will tell you the number of moles of each substance. So the steps involved in solving stoichiometry problems, there's 3 steps. You have step 1, you need to make sure the chemical equation is balanced. So make sure chemical equation is balanced, your first step. Second step is you need to convert grams to moles if needed. And the third step is use mole ratios to solve problems. So those are your 3 steps to use to solve stoichiometry problems. And then that last line, to fill in the blanks, you find mole ratios from the coefficients of a balanced equation. So again, your molar ratio, or your mole ratio, is the ratio of moles of substances in a balanced equation. For example, 2H2 plus O2 gives you 2H2O. That is a balanced equation, and it's asking for the molar ratio between H2 and O2. So you need to see how much H2 you need for how many O2 you need, and that is your mole ratio. You use the coefficients. So in this case, you have 2H2 and you have 1 O2. So your ratio is 2 to 1. And we write the ratio like that. The mole ratio between O2 and H2O, you're going to compare coefficient of O2 to H2O. And so for every one O2 you have 2 H2O. So your ratio between O2 and H2O is 1 to 2. And then the last one is asking for the molar ratio between H2 and H2O. So it says in your balanced equation 2H2 and 2H2O. And so your ratio is 2 to 2. But we like to write it the simplest as possible, and so 2 to 2 is the same thing as 1 to 1. And so that's what it means by mole ratios. You always use the coefficient or that big number in front to tell you the ratio. And again, if there's no number, like in your O2, that means that there's 1. So using stoichiometry to solve problems, and we're going to be using our conversions again. So these are mole-to-mole problems. First step, again, is to make sure that your equation is balanced. And if you double check that, that is balanced. And so the problem is saying if we have 2 moles of N2, how many moles of NH3 will be produced? So with your conversions, again, you need to you start by writing what you're given. So you have 2 moles N2. Step 2 of solving stoichiometry was to convert grams to moles if needed. This is already in moles, so we don't have to do that step. And the third step is use molar ratios to solve problems. So we need to use a mole ratio to convert moles of N2 to moles of NH3. So you set up your conversion. Remember, your units have to match diagonal, so if you start with moles N2, that means moles N2 has to go on the bottom. And you are trying to get from moles N2 to moles NH3. Now this step right here, you are going to use your mole ratio. And your mole ratio comes from your balanced equation. So you need to look at your ratio between NH3 and N2. If you look at your balanced equation, you have 2 NH3 for every 1 N2. So you put that mole ratio into your fraction. 2 NH3 to every 1 N2. Your units that are diagonal will cancel out. You are left with moles NH3, and that's what it is asking for. So you multiply 2 times 2 divided by 1, and that would be 4. Your unit is moles NH3. And it makes sense if you look at your balanced equation. If you start with 1 N2, you are going to produce 2 NH3. So with this problem, if you start with 2 N2, you're going to produce 4 NH3. So that makes sense. Problem 2, again, you need to start with writing what you're given. It's going from 6.00 moles H2, and it is asking for moles of ammonia, which is your NH3. How much would be produced? So you start by writing what you're given. 6.00 mole H2. Set up your conversion, and you need to use your mole to mole ratio. Mole H2. You match your units diagonal. Use your mole to mole ratio to solve. So you're trying to go from moles H2 to moles NH3. And the numbers, again, are going to come from your balanced equation, from the coefficients. So take 5 minutes to finish problem 2 and to set up and solve problem 3. Before we move on, we have to review how to calculate molar mass, so the mass of a compound. For example, molar mass of lead 2 nitrate, the formula is right here. You need to add up the masses of every element in it. So you've got your Pb, you have N, and you have O. If you look at your compound, you've got 1 Pb, you have 2 N's, and you have 6 O's. So you take the number of each element, you multiply it by the mass of the element found on the periodic table. Pb is 207.2. nitrogen is 14.0, and oxygen is 16.0. So you get your three numbers, and then you need to add those up together. And when you add those together, you should get 331.2. So the mass of that entire compound, which is also called molar mass, is 331.2 grams. Okay, so you are going to calculate the molar mass of magnesium nitrate and calcium chloride. Be careful with magnesium nitrate. You have to first find your compound, and remember to crisscross. This is a +2, and nitrate is a polyatomic. It's NO3 with a -1 charge. So make sure that you crisscross before you write your compound and get the correct compound before you find the mass. So take 5 minutes to finish the molar mass problems on this page. Okay, now that we reviewed how to find molar mass, we're going to do stoichiometry problems where it's going from mole to mass instead of just mole to mole. So we're adding one more step onto our conversion. So first step again is your equation balanced? And so if you double check this equation, it is balanced. Second step is convert your given to moles if you need to. This is already in moles. And then third step is use your molar ratios to solve. So you start by writing what you're given. 1.50 mole KClO3. And we are trying to get 2 grams of O2. So the first thing we need to do is convert this. Your units need to match diagonal, so mole KClO3 has to go on the bottom. And we are trying to get to grams of O2, but we have to go to moles of O2 first. And so this step, again, this is your molar ratio step. Moles of KClO3 to moles of O2. Your mole ratios come from the coefficients. So if you look up, your ratio is 2 KClO3 to 3 O2. Okay, so 2 KClO3 to 3 O2. Your units that are diagonal are going to cancel out, so this is going to cancel out. If you notice, the unit you are left with is moles O2, but it's asking for grams of O2. So we have to do one more step. Match your units diagonal, so mole O2 goes on the bottom, and we are trying to get to grams of O2, so that goes on top. And this is where you do 1 mole equals how many grams. So 1 mole of O2 is how many grams. Each oxygen is 16 grams, so that means O2 has to be 32 grams. So you've got 32.0 grams. Your units that are diagonal are going to cancel out. You are left with grams O2, and that is what it is asking. So you need to multiply all of your top numbers, get an answer, and then divide it by your bottom numbers. Get your answer. Your final answer, and we're going to do sig figs, should be 3 sig figs. And you should get 72.0 grams O2. Okay. On problem number 2, you're doing the exact same thing, you're just going the other direction, so you're going backwards. So it's starting with grams O2, and it's asking for moles KClO3. So first step is your equation must be balanced, it already is. Second step, your given has to be in moles, and so we have to convert that. So you start by writing what you're given, 80.0 grams O2. You need grams O2 per 1 mole O2. And then from here, this is going to be your step for you to use your mole ratios. And that should get you to your final answer. So take 5 minutes to solve that problem and compare your answer with the people around you. The last one that we're going to do is mass to mass, and this is just like before, but we're adding one more step, so it's just going to be one step longer. But you set it up the same. So how many grams of chlorine, if you look in your equation, that's your Cl2, can be liberated from the decomposition of 64 grams AuCl3. So, remember, first step is to make sure your equation is balanced, which it is. Second step, your given must be in moles, and your given is in grams. So that's going to be our first thing. We have to convert that to moles. Then we have to convert it to Cl2. So you start by writing what you're given, 64.0 grams AuCl3. Match your units diagonal. So we need grams AuCl3 per 1 mole AuCl3, because we're converting it to moles first. Grams AuCl3, you need to find the molar mass, or the mass of that whole compound. So you need to add the mass of 1 Au and 3 Cl's. That mass should be 303.5. Okay, so your units that are diagonal are going to cancel out, grams AuCl3. You're left with moles AuCl3. So now you can use, this is going to be your molar ratio step. This is where you use the mole conversions, or the mole ratios from your equation. So moles AuCl3 has to go on the bottom. And what you're trying to get to needs to go on top. You're trying to get to chlorine, so we need moles of Cl2 on top. So this is where you get the numbers from the coefficients. If you look back at your equation, you have 2 moles AuCl3 and 3 moles Cl2. So those are your numbers. 2 moles AuCl3, 3 moles Cl2. Your units that are diagonal are going to cancel out moles AuCl3. You are left with moles Cl2, but it is asking for grams, so we have to do one more step. This last step is going to be your 1 mole equals how many grams. So the mole Cl2 has to go on the bottom, and grams Cl2 on top. Grams of Cl2 is chlorine plus chlorine, which is 71.0. Your units that are diagonal will cancel out. You are left with gram Cl2. It is asking for gram Cl2. So you take all of your top numbers, get an answer, and divide it by your bottom numbers. So you have 64 times 1 times 3 times 71 divided by, in parentheses, 303.5 times 2 times 1. You should get an answer, and you should make it into 3 sig figs because you started with 3 sig figs, and you should get 22.5. Your unit is grams Cl2. Okay, so problem 2, you're going to set up exactly the same. So you follow how I did it in the problem 1 to solve problem 2, and take 5 minutes to do that one, and then when you're finished with that, you can move on to the practice problems, the last page of your packet.